Hello everyone, my name is Noman Iqbal and today I will tell you about a method to solve for finding the root of a differential equation. As we are familiar about numerical methods that are used to find the roots of the complex differential equations, one of the method which is known as false position method or regular false method, we will talk about it today we will learn how to solve how to find roots of an equation by using this method. This is the oldest method of finding the real roots of an equation. F of x is equal to 0 and closely resembles to the bisection method. Let's say that we have a function f of x is equal to y, and the goal to here is to find the value of x such that f of x is equal to 0. We need a point where the value of y is equal to 0. So if you can think that that point can only be lie on the x-axis, means when our function it will intersect on the x-axis, there the value of y equals to 0. So this is our goal, to find that goal, so that our equation or our whatever we can say that should be satisfied. Let's see graphically how it works. This is a xy plane, okay, and this is y-axis and the x-axis, and this is what our function line. This is our function, okay, and here it is intersecting on the x-axis. So that p of x is the point. That is what our goal we need to find. So here what we choose 2 points here, x0 and x1, such that f of x0 and f of x1 are opposite sign. The graph y is equal to f of x crosses the x-axis between the points at this point. This indicates that a root lies between x0 and x1, okay, and consequently. How it will works, let's say this is a point A and a point B, which is like 2 points here, x0 and x1. After the point, by using these points in our equation, we find another point, this is x2 value. So by using this value again, we will with another value of x1, we will use the next point, this will next value, this is x3, and so on. We will go further towards x4, x5, x6, and so on until we approximately reach to this point, okay. That's our goal. The equation of the chord joining these points, this A point and this B point, can be written as in the form of y minus f of x0 is equal to f of x1 minus f of x0 upon x1 minus x0. This is a slope, and into multiply by x minus x0. This method consists in replacing the curve AB by mean of the chord AB and taking the point of intersection of the chord with x-axis as an approximation to the root. The abscissa of the point where the chord curves the x-axis y equals to 0 means that point where the curve is cutting, okay, this intersecting the x-axis, that point can be found as by using this equation, x2 is equal to x0 minus x1 minus x0 upon f of x1 minus f of x0 multiplied by f of x0. So this is the equation. We will use it to find the differential, to find our roots. This is an approximation to the roots. As we know that we are unable to find the exact root, because it cannot be possible to find exact root. We will only find approximate root of the equation. If now f of x0 and f of x2 are two opposite signs, then the root lies between x0 and x2. Replacing x1 by x2, we obtain the next approximation value, and so on it will continue. But the root could as well lie between x1 and x0, because if they are opposite, they have opposite sign. So this procedure is repeated till the root is found to the desired accuracy. The iteration process based on one is known as the method of false. This process as we know that known as method of false position. So let's do an example on this so we can completely understand how it works. So example is here. This is find a real root of the equation x cube minus 2x minus 5 equals to 0 by the method of false position correct up to 3 decimal places. Means that our answer should be corrected up to 3 decimal places. So let's solve f of x is equal to x cube minus 2x minus 5. Okay, by using an initial guess. First we are using as 0. By using 0 as initial guess, we find the value as minus 5, which is a negative. Again we will use our second guess, which is 1, and we find the value as minus 6, which is 2 negative. But we need a positive sign because we will use only two opposite signs values. Because of the root will lie in between the interval of positive and negative. It will be in between them. So we need two opposite sign values. So after that we will start our iteration. So by using second guess value, third guess value, that is 2, we got the answer as minus 1, which is negative 2. At 3 we got as 16, which is a positive. So we can say that now our root lies between 2 and 3. So by using x0 is equal to 2 and x1 is equal to 3, we got that f of x0 equals to minus 1 and f of x1 equals to 16. Therefore, using these values in the formula, we get that this for x2 is equal to x0 minus x1 upon x0 upon f of x1 minus x0 into f of x0. We find out the value as 2.0588. Now by using this x2 in our equation f of x2, we find out that this is a negative root minus 0.3908. So what we will do, we will use it with x1 because it's a positive. It was the root was positive on x1, so here it is a negative. So these both are opposite values. We use now the root. Our root lies between x1 and between 2.0588 and x3. Okay, so now we will take x0 as 2.0588 and x1 as 3, and again we will put it into the formula, which is 2.0588 and minus 0.9412 divided by 16.3908 into minus 0.3908, and we will find the value as x3, which is equal to 2.0813, and so on. We will repeat until we will find our answer. So repeating this process, the successive operations, those are x4 here as 2.0862, x5 as 2.0915, and x3 2.0934. At x1 we got this value, and 8 we got this. But from x1 and x8 we can see that both the answers are closely same, as it was mentioned in the question. We need to our answer should be corrected up to 3 decimal places. So x1 is 2.094 and x3 is 2.0942. So these both are so here the x8 is corrected up to 3 decimal places. So hence the root is 0.94, which is corrected to 3 decimal places, and that is our answer. So this is how this method works. I hope this video will help you a lot. Thank you very much to listen me.